Okay, here we are for page 2. Again, more unit circle stuff. All of these are special angles on the unit circle. Sine of 330 degrees, that's the y value of at 330, so that's going to be equal to negative 1/2. Cosine of 270, so we look at our unit circle. Where is it? Where is it? It's 270. So the cosine is the x value, so that would be equal to 0. Tangent of 300, well, that's going to be equal to sine of 300 degrees. Sine of 300 degrees divided by cosine of 300 degrees. So sine of 300 is negative 1/2. Cosine of 300 should be a square root of 3 over 2. The 2's cancel out, leaving us with a negative 1 over the square root of 3. We cannot have a radical in the denominator, so we're going to multiply top and bottom by root 3, which should give us a negative. So 1 times root 3 is root 3. Root 3 times root 3 is 3. There we go. Next up is these other trig functions. So we got secant of 2 pi over 3. So secant of 2 pi over 3 is going to equal 1 over cosine of 2 pi over 3, like that. So that's going to be equal to 1 over cosine of 2 pi over 3 is going to be what? Negative 1/2. So negative 1 over 2. And then we keep change flip. So it's going to be 1 times 2 over 1, and the negative. So it should just be equal to negative 2. Cosecant is equal to 1 over sine, and this is going to be 7 pi over 4. Over 4 is going to be, so it's going to be 1 over 4 should be square root of 2 over 2, and that is quadrant 4. Quadrant 4, so it should be sine is negative in quadrant 4. So we do the whole keep change flip, and we get negative 2 over the square root of 2. And we do our little rationalize the denominator trick. So our final answer ends up being negative 2 root 2 over 2. Cotangent of pi over 6 is going to be equal to, so cotangent is cosine of the angle divided by sine of the angle. Cosine of pi over 6 is square root of 3 over 2, if I remember correctly. And sine of pi over 6 should be 1/2. Once again, the 2's cancel out. Denominators cancel out, makes things much easier. Square root of 3. Finally, these last ones. Secant, that is too large. 17 pi over 6 is too large, so we're going to subtract 2 pi from it. We're going to subtract 2 pi. There we go. So what we're looking for now is going to be secant of 17 minus 12 is 5 pi over 6, which is equal to 1 over, so secant should be paired with cosine of 5 pi over 6. And cosine of 5 pi over 6 should be a negative root 3 over 2. So negative root 3 over 2, flip it, is negative 2 square roots of 3. And then we have to do our little trick again, square root of 3 divided by square root of 3. So multiply top and bottom, and we should get 2 square roots of 3 over 3. So cosecant has, this particular cosecant has two issues. One, it's too big, like that number is not between 0 and 2 pi, and then also this is negative. So cosecant is 1 over sine, and since sine is an odd function, cosecant is an odd function, so we can use the double angle identity to bring that negative out. So this would be negative cosecant of 7 pi over 3. Then we can subtract 2 pi. So we're going to subtract 6 pi over 3. 7 minus 6 is 1. So what we're looking for is negative cosecant of pi over 3, which is equal to 1 over sine of, or sorry, negative 1 over sine of pi over 3. And sine of pi over 3, if I look at my unit circle, should be square root of 3 over 2. So then I would flip that to get negative 2 over the square root of 3, which again, do the whole rationalize the denominator, and you should get negative 2 square roots of 3 over 3. There's not a lot, if you notice, there's not a lot of variety in these. Sine, cosine, tangent are all going to be 1/2 square root of 3 over 2, or square root of 2 over 2. And then tangents either going to be square root of 3, 1, or square root of 3 over 3. Those special angles all repeat. They all repeat. Finally, we have cotangent of 5 pi over 4. So that is equal to cosine of 5 pi over 4 divided by sine of 5 pi over 4. Cosine of 5 pi over 4 is negative square root of 2 over 2 over sine of 5 pi over 4 is square root of 2 over 2. So this should be negative 1. Root 2 over 2 divided by root 2 over 2 is just 1. Okay, these next ones pretty much all work the same. We need to find cosine if sine is equal to 3/5 and theta is in quadrant 2. So we're going to use, so we're finding cosine. So we'll use a Pythagorean identity. Cosine squared theta is equal to 1 minus sine squared theta. We'll use that version of the identity because I need to find cosine. And so this is going to be equal to, I'm going to go ahead and get a common denominator because once I square this out, 5 squared will be 25. So that'll be equal to 25 over 25 minus 9 over 25, which is equal to 16 over 25. And then we square root both sides. So cosine of theta is equal to plus or minus 4/5. And because we are in quadrant 2, in quadrant 2. In quadrant 2, cosine is negative, so it's going to be negative 4/5. In quadrant 2, cosine is less than 0, negative. Now we're going to find sine squared. So we know that we find sine theta. We know sine squared theta is equal to 1 minus cosine squared theta, Pythagorean identity, one of the most important things out there, especially for this class. So that would be equal to 1 minus a negative 1/5 squared. So that's going to be 25 over 25 again, minus 1 over 25. So sine squared theta is equal to 24 over 25, square root both sides. And we get sine theta is equal to plus or minus the square root of 24 over 25. Before I simplify this, I'm going to get the final answer. It's important if you're doing reciprocal identities. Makes things a little bit easier in the long run. So what we're going to do here is first we're going to see that we're in quadrant 3. In quadrant 3, sine is less than 0, so sine is negative. So sine theta is equal to negative, and then we could simplify this, factor out a 4. So root square root of 4 becomes 2, square root of 6 over 25. 2 square roots of 6, negative 2 square roots over 25. 2 more. So this time again, we're going to go cosine squared theta is equal to 1 minus sine squared theta. So we can, from here, we'll just do 1 minus negative root 3 over 7 squared, which should give us, we'll do 49 over 49 minus, there should be 3, root 3 squared is 3 over 7 squared, which is 49. So we should get 46 over 49 is cosine squared. So cosine, square root both sides. Cosine is equal to the square root of 46 over 7, plus or minus. We are in quadrant 4, and in quadrant 4, cosine is greater than 1. It's positive, so we'll use positive. So cosine of theta is equal to the square root of 46 over 7. So here we're looking for tangent. Actually, this one would not work. Omit that one. Omit that one. Cosecant cannot be less than 1. Cosecant has to be more than 1. If I wrote this in properly, this should say 5/3. That should say 5/3. Cosecant cannot be less than that. Cannot be less than 1. It's just mathematically impossible. It's undefined. So if we wanted to solve this, so let's say that cosecant is equal to 5/3, and if we wanted to solve this, because cosecant is equal to 5/3, we should know that sine is equal to 3/5. If cosecant is 5/3, sine is 3/5. So, knowing that, we could find cosine the same way we did before. So cosine squared is equal to 1 minus sine squared theta. So cosine squared theta is equal to 1 minus 3/5 squared. If we go back up here, we notice that this is the same number, 1 minus 3/5 squared. We ended up getting 4/5. So that's going to happen again over here. They are the exact same numbers and the exact same problem. So it's going to be plus or minus 4/5, but we are in quadrant 1. We are in quadrant 1, so cosine of theta is equal to 4/5. But that's not what we're being asked. We're being asked about tangent. So tangent is sine theta over cosine theta, which is going to end up being sine was 3/5 over 4/5. Those cancel out, leaving 3/4. So again, I printed that wrong. It should be cosecant has to be greater than 1. It cannot be 3/5. Never, ever. We'll get more into that next week. But if I put that in right, this is how you would solve it. You just change everything to sine and cosine. Every trig function is defined by sine and cosine. So once you find those, you should be fine. You can find everything else. Okay, I'll see you on the next page.